finish, and then I will hand it back to you. For some of you that, why are you talking while I'm talking? For some of you that were put the effort into the test, you did fine. I mean, that was somewhat of a challenging test, with the exception of Jace. You guys don't have summer. You have a summer reading list. They're going to give, because you go to LTA, they're going to give you a book that's this thick, right, and tell you need to read it and write a report on it over the summer. I'm just going to tell you, I'm not the English or language arts teacher or the literature person. The kids that wait until the last week to try to read the book, you cannot read that book in a week. Why?
The book, Julia probably.
All right. I would personally, hey, figure out, a 2-week time frame, read the book. The longer you wait for it to, thank you, the longer you wait or closer it is to the start of next year, the better you're off. Better off. They will give you a test on the book as well, too. Okay. So it's not one of those things where you're like, well, summer, I'll just take no, they're going to use that book at the start of class. Next year in ancient literature, they use that book. Okay. Talk to your English language arts teacher when they physically give you the book. I want to say it's the, I don't know. I'm not going to get involved. It's the Odyssey. It's a great book. Yeah. Yeah, we give it to you in Greek and ask you to translate.
What? Oh, they had that literally.
Wait, we're gonna have to translate stuff? Dude, I suck at Latin.
Hands down, I'm not the English language arts teacher. All your questions are sure about that.
I don't want to read this.
Occasionally, the history teacher also provides. In the past, sometimes they have something. You're going to talk to your history teacher if there's a summer reading list for history as well too. All through high school, every summer there's a reading list. Right? We don't let you take a summer off of doing nothing if you go to our school. Education doesn't stop simply because it's summer. Right? All right, here we go. It's going to require you to take a lot of notes today. A lot of notes. Hands down. Here we go. It is a worksheet tonight for homework. If you understand what I teach you, this is literally pretty easy homework. The issue is you don't know anything what I'm about to teach you. Okay? It will require what's in front of you to be filled out perfectly in order to do this homework. You'll pay no attention, you have no chance of doing tonight's homework. None of you know what we're about to do. None of you. New math, you've solved equations. Great, you've done a little bit of algebra 1. We're starting out. Algebra 1 is, for most people that later on in life to say, yep, I was no good in math. Algebra 1 is the one where they say, okay, I was doing okay in math until algebra 1, and then they lost me. Okay? The way that doesn't happen to you is starting on day 1, today's day 1, is you pay attention. You don't let the teacher ever teach you anything that you don't understand. You got to think about the inner Kai inside of yourself. Don't ever let the teacher say something that you don't get or understand. I don't understand. Okay. Lots of questions to me. Algebra 1, it's a big step up. Myself, when I sat in the 7th and 8th grade classroom, my one thought about math was this. This is the same math out. Okay. My thought in math in 7th and 8th grade, probably in 6th grade, was the same thing. It was like, when are we going to learn something new? It's like every year we do the same stuff. Christian, I'm sure, has had this conversation with himself plenty of times. He's even sent me an email this year, right? I already done all this stuff. When are you going to teach me something new, right? Algebra 1 is when it happens. So I don't know, say 3rd grade, once you learn long division or wherever that happened, 4th grade onward, it's the same stuff every year. First couple chapters are add, subtract, multiply, and divide. Then they throw in some decimals, and they throw in some fractions, and then maybe there's a proportion involved. And then there's a little bit of geometry. Then they solve some equations. That kind of was the new thing starting around 5th or 6th grade. But nothing's really new. It's like if you open up the course 1 book and the course 2 book, chapter for chapter, it's the same stuff. It's just slightly harder in algebra or in course 2. Algebra 1, oh no, every day it's new stuff. If I showed you the stuff that we do in Algebra 1, you guys would pee your pants right now because it looks so weird. You have no frame of reference. Like, well, I've never done anything like that before. I don't know what to do. I also give this speech every year, and then I get kids in chapter 1 in Algebra 1. They're like, you were full of it. This is easy, right? Because chapter 1 and well, a little bit of chapters, but chapter 1 is easy in Algebra 1. Maybe they do that on purpose to give you some self-esteem, boost of confidence that algebra won't be so hard. It's hard. You don't believe me? Ask anyone in the Algebra 1 class right now in 9th grade and ask them whether or not Algebra 1 is easy or hard. They're all going to say the same stuff. I was like, oh, it's hard. It turns out that all math beyond 8th grade math is hard. It's just, it's different. Every year it's different stuff. We no longer teach you the same stuff over and over again. Every day you learn something new. You look at this sheet right now, and you look at the last question. It says standard form, degree name, term name. You have no frame of reference. You don't even know what they're asking. That's what Algebra 1 is like. The key to doing well in Algebra 1 is you sit in class and you pay attention. You go home and you do the homework. If that doesn't happen, plenty of kids get A's in 7th and 8th grade math. They get to Algebra 1 and that A turns into a C because they haven't developed the skills of being able to sit in a math class, pay attention, and go home and do their homework. I mean, I can already point to the people who will probably not pass because they have not set up the skills necessary to do well in higher level math. Okay? If you don't change the way you do things, do your homework all the time, ask questions, pay attention, take notes, you will absolutely fail Algebra 1. No joke. Like, no joke, fail. Right? When you get to high school, what happens when you fail a course is you don't get credit for it. Right? Two things can happen. We either make you, if you fail enough course, we make you repeat the grade. And then two, if you don't get credit for the class, you don't graduate high school, right? You have to get, we'll talk about it next year, you have to get so many credit hours to pass high school. If you don't pass any course in high school, you don't get credit, you don't pass. I don't care if it's underwater basket weaving. If that's one of your electives and you fail it, you don't pass high school. You have to pass all of your classes, okay? 7th and 8th grade, we talk about the core classes. You have to have so many. We don't talk about the electives because, well, the story we don't tell you because we know some kids would literally fail it on purpose is you can fail an elective and still go on to the next grade if your GPA is higher. That goes away in high school. In high school, you don't pass the class, PE, whatever. You just don't get credit for it. Come senior year, you start counting up how many passes in that class, and you get to 26 and not to 27. You don't graduate high school. 27 out of 28. 27 out of 28. You'll take 28 classes. You got to pass 27 of them. You can't ever fail a core class, but technically you can fail one course. As long as it's an elective. All right. With that out of the way, let's learn. Hey, the first lesson in Algebra 1 is called polynomials. This is chapter 13 of our book. We'll only get 2 sections and then we're done. And it'll be okay because you will get this literally the same class again in Algebra 1. All right, so this is day 1 of Algebra 1. We're just going to be doing this thing called classifying polynomials. The purpose of this is because the terminology that we use when we teach the class is what you're learning today. I'm going to talk about this thing like I talk about circles and I talk about linear equations. We'll be talking about polynomials in Algebra 1. Right now, probably none of you know what a polynomial is. By the end of the class, you all know what a polynomial is. It's a pretty simple thing. As always, in Algebra 1, if you pay attention, things will go okay. You stop paying attention, you don't do your homework, you're going to fail, right? If you'd like me to show you a test right now of what it looks like, I can. It's not anything that you have any frame of reference on to solve. All right, write this. Box 1 has 4 boxes. In the first box, call that 1A, write this down. The building blocks of algebra is called a monomial. Monomials come in 3 different flavors. They're either a real number, and yes, we start using this word real number, and it literally means it's not imaginary. Imaginary numbers we don't get until junior year high school in math, algebra 2. It's a real number or a variable, or the product, that's fancy word for multiplication, of a real number and a variable. So it comes in 3 flavors. If you are a monomial, well, you could be a real number. Hey, look, there's an example. 2 is a real number, so 2 is a monomial. Or any other number you can think of. Real number, so it includes fractions and decimals, positive and negative numbers. Could be a variable. Variables are monomials. Or it could be the product of real numbers and variable or variables, plural. All 4 of these are the different flavors. Well, there's only 3 real different flavors. All 4 of those are different examples of monomials. So for most people, they look at it and they're like, well, what's a monomial? And the answer is yes, any one of those is a monomial. Today's class is only about names. No adding, subtracting. I'm lying slightly. In class, we'll do a little bit of adding, subtracting, but not for homework. All right, so think about this. If I have a monomial, what's a monomial? Well, it's a real number, a variable, or a product of a real number and a variable or variables. If I take a monomial and next to it I put another monomial, I can't put multiplication or division because that would make it a monomial, but I could put addition or subtraction. If you do that, if you take 2 or 3 or 4 or 5 monomials, and between them you put either a plus sign or a minus sign, you've made something new. Instead of having a monomial, you've made many monomials. Greek or Latin for many is, the word for many. If you live in the South Pacific, all the islands there are many islands there, and the people there are called
Monomials.
Anybody? Starts with the letter P.
People.
They are called
Persons.
They're called Polynesians.
Oh.
Okay. So if you put monomials together with addition subtraction, you have made not a monomial, you've made a polynomial. That's in box 1B. Polynomial is just 2 or more monomials joined together, not by multiplication or division, that would make a polynomial. A monomial, but they're joined together by addition subtraction, that makes a polynomial. Polynomials are just monomials joined together with addition subtraction. This is algebra 1, and this is how it goes. Like, well, I learned 2 new things, right? Like that. But neither one of those 2 things were that hard. Okay, it's just words at this point. So that part isn't too bad. Today is not a hard class, by the way, but it is brand new, every bit of it. Some examples of polynomial, you don't need to write down the examples, right? Well, 2x, well, maybe I need to make it 2x plus 1, because 2x by itself is just a monomial. So if I put a plus 1 next to it, I made it into a polynomial. All of these are examples. Tonight for homework, they're going to give you something like this. They're going to ask you 3 questions. They're going to say, put it in standard form. You're going to say, what's its degree name? And what's its term name? All of that is the rest of the class.
Now we're gonna do like the actual problems.
We're about there. Polynomial, expression with multiple monomials connected by addition. This is the key here, connected by addition subtraction. If it's connected by multiplication, you actually got a monomial, not a polynomial. Okay, so the easy stuff is over. Now comes it's weird stuff. Here we go. So the first weird thing, it's something called degree of the monomial. Your mom says, oh, are you sick? She puts a thermometer in your mouth and she says, what's your degree? Right? In math, we have the same concept. We take the degree of what's called the monomial. Okay, this is your first. You got to memorize this. This is just by definition. It says you take the sum means addition, you add the exponents of the variables. You got a monomial, you add the exponents of the variables. Guess what it doesn't say? It says you add the exponents of the variables. Guess what it doesn't say?
Subtract them.
Doesn't say subtract, and it also doesn't say you add the exponents of the real numbers.
Oh.
So the only exponents we're going to add are the exponents attached to the variables. Whatever that number is called the degree. So in math class, I'm going to hand you a monomial and say, what's the degree? You're going to take the variables and just add up the exponents. That's it. That's not hard, right? Might be hard to remember it, but it's not hard to do. Okay, so I'm going to give you some examples. I'm going to show you a monomial. You're going to look at the variables, and add up the exponents. I got to make sure I'm recording. Yes, I'm recording. Good.
You are.
Thank you. So here we go. Algebra 1 is easy because guess what the degree is?
2.
If I had given you this 20 minutes ago, none of you would have gotten it right. But with a little bit of explanation, everyone gets it right. That's what Algebra 1 is like. Algebra 1 can be a bit more challenging than this at times, but the key is you pay attention, you show up to class, you do the work, and you do your homework, and then you check it next day when I call out the answers. If you do that, then all of a sudden you become smart, right? You're like, well, I can do Algebra 1. It's nothing challenging going on here. Yeah, the degree is 2. What's the degree? It says you're supposed to add the variable's exponents. So 2 plus 3 is. It turns out in Algebra 1, rarely do you do adding, subtracting, multiplying, dividing with weird numbers that are hard to do. Most of the adding, subtracting, and multiplying and dividing that we do in Algebra 1, most, not all, is done with numbers like 2 and 3. You've already done all the hard work leading up to 8th grade. Add, subtract, multiply, and divide with fractions and decimals. Algebra 1 just doesn't do anything more challenging. The numbers don't get harder. The math becomes very different, though. Okay, what's the answer?
9. Wait, no.
9.
Why is it?
9.
Why is it 9?
Because you add up 4, 2, 3.
Read what's here.
The sum of each exponent of the variable.
Because 7 is a variable.
Yes. Oh, so it's 5.
So it's 5. We never add up the power of the real number. Technically, this has a power. It has the power of 1. We don't say 1 plus 2 is 3. We only do it for the variables. Okay. There's your first quote, complicated Algebra 1 concept, degree of a monomial. If you can remember the rule, you'll never make it. Oh, by the way, we use this almost on a daily basis. I'll say take a degree 2 monomial and do this. I'll say take a degree 5 monomial, do this with it. Okay. We learn more what it means when you are a degree 2 or degree 5 as the math gets harder. In Algebra 1, other than naming the degree, we don't do any math with anything higher than a degree 2 monomial in Algebra 1. Now, we will occasionally, like today's class, see degree 5. We will occasionally in Algebra 1 see degrees higher than 2. We just don't do anything other than like add and subtract with them. Okay. When we get to Algebra 2 and higher, we'll start seeing degree 3 and 4 and so forth and so on. Okay. Go ahead. Do the whole box.
Are you gonna go get Kai? Are you gonna go get Kai?
Do the box.
Okay.
So I can go get my student in the hallway.
Don't yell at him.
All right, do the work. And be quiet.
He's like boring. Go.
All right, everybody done?
Yeah, it's easy.
First one, what's the degree?
0.
Wrong.
How?
It's 2.
I got 1, 2, and 0.
It's 0 because there's no.
What's the degree of any number?
1.
There's a 1, a 1, and a 1. It says degree of monomials, we add up the exponents of the variables, therefore it has degree 2.
Bro, that was hard.
Hey, you want to be out in the hallway?
No.
Second one, what's the degree now that you see what the answer to the first one is?
4.
What is it?
4.
It looks like an equal sign on our sheet. Not a
What looks
C.
like an equal sign?
It looks like an equal sign on our sheet.
It does.
It's there, it's just a little faint. Winter is saying 5. Mr. F in the front is saying 4. Who's right?
It's 5.
Oh, now he's changing. All right, Mr. 5. Very good. Anybody need an explanation why it's 5, not 4? Okay. All right. What's the degree of 11?
0.
We call them constant terms. Any constant term has a degree 0 because there's no variables. Okay. Now we do the last ones really quick. This one is
3.
and this one
0.
is 3 and 0. There we go. Degree of monomial, no big deal once you learn it. And by the way, you learned it. Good job. There's your first somewhat challenging thing, which is pay attention in class so that you don't wind up in the hallway or you don't wind up at the end of class like, wait, what was degree of monomial? I forget because I wasn't paying attention. All right. The big so what is it turns out that you can do math with like degree monomials. It turns out that you can add and subtract like degree monomials. You are allowed, and this is not new for you because we've been doing this. I just haven't formally introduced this to you. I just said you can add and subtract like terms. What does that mean? That means you have 2 monomials that have the same degree. If they have the same degree, you can add them together or subtract them as long as the variables are the same. So we're still stuck with, you can add x's with x's, y's with y's, but as long as the degrees are the same and the variables are the same, you can add and subtract them. Okay? So how does that work? Well, you can, this is not an algebra 1 problem, but notice I got a degree 1, a degree 1, they're both x's. What do?
Add them.
I don't add the exponents, I don't add the variables, I add the numbers in front, which in a later class we're defined as the coefficients. So we can add the coefficients. This is something you already know how to do, but just tying it into the degree. What do we use degree of monomials for? Well, there's one reason, or there's one application. Okay. Hey, I got a degree 2 monomial, degree 2 monomial. They both have x's. We can add them together. Therefore, the answer is
4. It's 4 because 2 plus 2.
you don't add the exponents ever.
How?
Okay. You add the coefficients. Therefore, the answer is 8x squared. If you need to think about this in terms of physical objects, if x stood for the number of peanuts, right? There's 2 bags of peanuts, there's 7 bags of peanuts, we have 9 bags of peanuts. Okay? We don't add the exponents if we're adding monomials or subtracting them. Okay? What's the answer? Read what the previous slide just said. It said that you are allowed to add when the terms have the same degree. What's the degree of this one? What's the degree of this one? Can't add them together. You're not allowed to add or subtract unlike terms. We define unlike terms of terms where the degrees are different or the variables are different or both. Hey, I got an h to the second, I got h to the third. You can do nothing with them. So in algebra 1, guess what the answer is?
Undefined.
Not undefined. The answer is not no solution. It's just whatever you start with is what you finish with. If you have unlike terms, there's nothing you can do. Like, are they literally going to ask a question like this? It'll be part of a larger question, but the answer is yeah, you literally just rewrite it again. It's not that there's no solution. There is a solution. There's nothing you can do. Generally speaking, we're doing a process called simplifying. We would say that this bottom one right here is already in simplest terms. We don't say reduce, but simplest terms. Okay. Cool. What's the answer?
Negative 5x2.
If the powers are not the same, you can do nothing.
Oh.
Powers are not the same, so the degrees are different. Therefore, we can do nothing. The powers are the same, and the variables, just got to be careful. Because if it said 2a squared minus 7x squared, we still couldn't do anything. It's only when the powers are the same, the degrees of the monomial, and the variables are the same. You've not seen one like this before. This is an Algebra 1, the first real Algebra 1 problem here. Okay, let's follow the rule. What's the degree of this binomial?
2.
No,
3.
this is 3.
This is 3.
2 plus 1 is 3. What's the degree of this one?
3.
3. Well, the degrees are the same. Are the variables the same?
Yeah.
Further, we got to say is the power of the x the same as the power of the x, the power of the y. Same. In other words, we got to make sure they're like terms. When they're like terms, we simply add the coefficients. So therefore, the answer is
8.
squared y. Okay, you've not done one like this. This is, honest to God, what most problems look like in Algebra 1. Something like that. Okay, do those all by yourself. We did one for adding, now we're doing one with subtracting. If the degrees are the same, if the variables are the same, and the powers to the variables are the same, you can add or subtract the coefficients. The coefficients are the numbers attached to the front of each term.
I'm really lost. Lost.
Same or different?
Same.
If they're same, you go to these numbers and do whatever it says.
So 2 minus 7.
That's not a 2,
Negative 2.
which is,
5.
are you in Algebra 1 or are you in 7th grade?
Algebra 1.
So when the signs are the same, what do you do?
Add.
Final answer?
Oh.
9x2
Nope.
Negative 9. Negative 9.
Okay,
Calm down, dude.
number one mistake in Algebra 1 is something called dropping the negative. And what happens is because almost every problem we do involves positive and negative numbers, it's very common. And when you rush yourself, you concentrate so intently on, wait, signs are the same, so we got to add 2 plus 7 is 9. You're so happy that you know you got the right answer, you forget that you're adding negatives, and you drop the negative, right? In other words, you leave the negative off, even though you knew it was negative.
Oh, okay.
Like terms or not? They are not like terms. We can do nothing with them. One has a degree 3, one has degree 2. There's nothing you can do. Like terms or not? Yes, they are alike. So you do whatever it says in the coefficients. It says negative 6 plus 7, which is 1. So the final answer is 1x to the 4th. The reason why there's pictures of apples and oranges, because this is the metaphor, the analogy of you can, add apples with apples, oranges with oranges. Yes, there could, you mean the x? There could be. I mean, if you want to say the answer is 1x to the 4th, okay, it would never mark it wrong. You talking about that y? You could. If you wanted to. You will never see any book that does that,
Why
but
is
you
it?
could.
Why is it not x8?
Because remember, when we're adding,
Oh.
we rewrite the variable in its power. Yeah. All right. Last part of the class is you better copy this down. You'll have no idea what to do if not.
Okay.
All right, here we go. If a monomial has a degree, hint, 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 then a polynomial must have a degree. So here's how that works, and this is by definition. Okay, they could have made this up anyway. This is how they decide to give you the degree of a polynomial. So here's what they said. Write this down. We're on what, C now or D? The degree of the polynomial, this is the only challenging one and the one you have to memorize, is you pick the monomial inside the polynomial that has the highest degree, and that's the answer. So I'm going to give you a polynomial. Remember, that's many monomials joined by addition or subtraction. You pick the monomial that has the highest power, and that ends up being the degree of the polynomial. Algebra 1, issue number 2. We wind up dealing with this stuff, like I said, that you have no idea. Like, it's not like we're talking about triangles or we're talking about two fractions added together. All of a sudden, we're talking about words that if you don't have the ability to sit there for 50 minutes in a class and pay attention, boy, will you get lost really quickly. Like, what happened? What's a polynomial? That sort of thing. If you had not paid attention 10 minutes ago when I gave you the definition of polynomial, then my explanation of degree of a polynomial, you got no chance on. Don't let me go past anything. I will be your algebra teacher next year. Don't let me go past anything that you're lost on. You ask the question. If there's one that causes problem, it's degree of the polynomial, because they forget what the definition says. It says you take the whole darn thing and you look at each monomial. Remember, monomials are linked together by addition or subtraction. So this has two terms, 1, 2. Why? Because, well, there's two things that join with addition symbol. We look at each one. What's the degree of that one? What is it? What's the degree of this one?
1,
What's bigger, 2 or 1?
2.
So the degree is 2. You don't add them together. You just pick the one that has the highest, and that's the degree of the polynomial. This will be the first one that kids will generally get wrong. The kids that are paying attention, everybody gets monomial. We get to polynomial, all of a sudden I lose them. Yeah, that's correct.
This is easy
Okay. What's the degree of 3?
now. 1,
Absolutely not.
0,
No variable, so it's 0. What's the degree of this one?
2.
Wrong. It's 5.
How?
2 plus 3 is 5.
But you said that
2 plus 3 is 5.
But you said earlier, don't have to.
2 plus 3 is 5.
That's for a different thing.
That's
I
for a
said
completely different thing.
Thing.
You find the degree of the monomial first. It's 5. You just did that in box number 2. Okay. You find the degree of each monomial. It's 5 for this one. It's 0. You pick the biggest one. Oh, it's 5. You're done. It's a degree 5 polynomial. In algebra 1, we deal with up to a degree 2 polynomial. Yeah, I'll give you some adding, subtracting ones like this, but we do nothing other than add or subtract. We will do real, honest to God, weird math with degree 2 and lower. So degree 1, degree 2 is what algebra 1 is all about. All right. What's the degree of 6?
This is nothing.
What's the degree of this one?
1,
What's the degree of this one?
2,
Is it 6 or 2?
2. The one on the left.
We never care about the real number. We only care about the variables. So this one has degree 2. This one has degree 1. This has degree 0. What's bigger, 2, 1, or 0?
2.
So this is a degree 2.
This is easy.
Don't care about it. Because by definition, we don't care about it. By definition, we said the degree of the monomial is only the degree of the variables. Okay. Cool. All by yourself, box 4.
Done. Did I get mine right?
First one is wrong, second one's right. Third one's right. Anybody lost?
Are we gonna have a quiz or test on this?
Semester final.
This is going
You tell me, is it easy or hard?
hard.
Finding the degree is very easy.
Or just say it's easy, but it's so easy.
Jenny, they just need to pick the biggest number. That's it. There's no math involved.
Actually, Mr. Chartier, if you can go back to the next, or the last screen, I think I know where everyone's getting confused.
Go for it.
So on the second one, people are forgetting that you add the X and the Y because they are attached to the 7. Because then when you look at this, the bottom one, you see how the X squared and the X are separate, and then you pick the one with the highest number.
You got us.
You got it. Well, I'm sitting back here and I'm learning too, and I'm thinking, if I'm confused.
All right, here we go. For this first one, what's the degree of the polynomial? You pick the one with the largest one. It's 4. Right? Okay, cool. So degree 4. This one right here, what's the largest?
2.
Oh, it's 2. What's the largest?
0.
And you're done.
Dude, this
Yes.
Isn't the 6 a monomial?
Remember, we define a monomial as a real number. Well, 6 is a real number. So her argument is, well, you didn't really give us a polynomial there. Okay, how about 6 plus 1? All right. And then to further argue, well, that could be turned to 7. Okay, it turns out, and I don't really usually say this because it just causes confusion, that any number can be considered a polynomial as well because of that right there. But that just causes confusion, so I don't do that. All right. Algebra can be hard at times, and usually it stems from the fact that you sit there, you don't pay attention, and you don't ask questions. You're like, I see he wrote 6, I'm getting 4, I don't know why. All right, now he's talking about something else, and you never get that question answered, and then you're lost. The real truth behind Algebra 1 is, okay, I'm a math person, so and I always think that Algebra 1 is easy, but the real truth is it's not as bad as you think. It's just that you walk into a math classroom with an inability to understand what you need to do to be successful. Next year, when you walk into freshman history class, if you don't have the ability to sit there and take notes in a lecture and understand that when you see something that's underlined, it's probably important and it should go in your notes, you don't have a chance of passing that class. It's 100% lecture. You sit your butt in a chair, you listen to an adult show you slides and pictures and talk about things, and you got to sit there and be able to write down those notes. If you're a kid that can sit there and be quiet, right? What generally happens is that you're deemed as, oh, well, that kid can behave very well. You know, the kid that can't sit there and be quiet all the time winds up in the hallway. But the real idea of can you pass or fail is your ability to take notes. And the issue is that, especially like in a history class or an ancient lit class, when you're talking about the Odyssey and you're asked a question about, well, what happened? If you've never read the book, right? If you don't have the ability to read a book, boy, will things go wrong. Algebra 1 is where I'll stick to. Like I said, if you can sit there and pay attention, it's not like it's going to be that hard, right? Most kids by the end of Algebra 1 say, oh, Mr. C, you were full of it. Algebra 1 wasn't that hard. Yeah, it's because you're one of the kids that figured it out. There's plenty of kids that don't figure it out. And they come in 2 flavors. The first flavor is they literally just sit there and do nothing, never do their homework. There's no chance of them failing. The second one is that they truly have issues with math, but they're too afraid to ask questions. Like they're willing to, well, I know what I'm supposed to do, but they're too afraid to ask. There's not a single question that ever doesn't get asked that ever does you well. Like the unanswered question, or the unasked question, I should say, never does you anything for it. You got to ask the questions. And it's, the standard cliche of, if you don't ask the question, there's no dumb question. And the kid next to you probably had the same question you were too afraid to ask. That's true. It's cliche, but it's true. All right. So here we go. Another new concept. But boy, they just come at you every single day. Every day, it's not going to be like one. We're just going to learn this one little new thing. It's going to be like 5 or 6 new things every day. It's just a word. It's called standard form of a polynomial. It's a pretty easy concept, but it's new words, right? It's called standard form. It turns out that when you take a polynomial, 2 or more monomials joined by addition or subtraction, and you write them in descending degree order, you have what's called standard form. Most of the time, I will hand you polynomials in standard form. So what does that really mean? What's the degree? What's the degree? You need to write it as 2, 1, not 1, 2. So whatever the highest degree monomial, it goes first, then the next one, the next one, the next one. When that's done, you have it in standard form. You told me that this 2 is bigger than this 1, I agreed. So the way I should write this in standard form would be the 3x squared comes first because it's got the highest degree. And then the next one, and the next one, and the next one in descending order. Not a hard thing to do. If you can't remember, though, what it means, then, gosh, homework tonight says write them in standard form. So you have to understand what that means. We take a polynomial and we write it in descending order. Hey, what's bigger, 3 or 4?
4.
So the 4 comes first, but you take the whole darn thing. So the whole darn thing is an 8x to the 4th, negative 8x to the 4th. 2x to the 3rd is positive. Yeah.
That word there, like an H.
Where?
The word.
Oh, yes. Very nice. No one's caught that in 3 years. Yes.
So, if you have a larger, regular number, Will that go in front or is it just y?
Nope, it's the highest degree comes first, because remember, a constant plus 6. A constant has degree 0, so it always comes last. If you have a constant, always comes last. And we'll see that. Back, here's 1. Hey, what's the highest degree here?
3 or no 4.
So that comes first,
Then 3.
second,
Then 2.
third,
Then 1.
0.
fourth.
Or 0.
Okay, so why can't you just take it to just the polynomials? Like,
What
why
do you mean?
can't, like, why do you have to attach the 3 and x and 2 and x and all that?
Because this is the actual expression right here. The expression is 2x plus 3x squared. The better question is, why do you need it in standard form? Boy, that's a question I got to wait till next year to answer. Turns out that we have a lot of stuff that we get if it is in standard form. If it's not in standard form, technically first step is you put it in standard form so that you can get some information. I can't give you a better description or explanation other than you will like it when it's in standard form. You will not like it when it's not in standard form. A whole lot of things come about because it's in standard form. Yeah.
What's the last one that has addition and subtraction? Like, when I want to move numbers, how do you get, like, which ones are addition, which ones?
So remember, you always look to the left of the term to figure out whether the term is positive or negative. So if there's nothing there, it's always positive. Okay, so we just look to the left. This one's positive, this one's negative, this one's positive, that one's positive. Okay. Hopefully you've been doing that before when we had, I mean, if I literally erase all the x's there and just leave the coefficients, technically you've done that before. This would say 2 plus 1 minus 2 plus 1. And supposedly, since you've just now finished course 2, you know how to handle that. You know, which sign is positive, which is negative. We always look to the left. All right, standard form, do it. Box 5.
Did I get these right?
We'll find out here in a second. Oh, I need to change my spelling, which I did on multiple slides here.
Wait, what? Doesn't she get a point?
Not for formatting, but she gets my undying gratitude of making me look like I can actually spell when clearly I can't.
Wait. Oh, you messed up on that?
I did.
Ooh. I've got PlayStation 5.
I need you to do your math.
I have.
And the next slide, it's jacked up too. All right, everybody good?
Yep.
All right, Angie, standard form, give it to me. Biggest one first.
8. Wait, what are you?
We're gonna rewrite this one in standard form.
Okay.
So you start with the highest degree monomial, which is 2. So we write. Think of these as pieces, right? I've got 3 pieces, right? Here's a piece, here's a piece, here. Now we're gonna arrange those pieces. Stop. So it goes from least to greatest. And I don't mean these numbers, I mean the monomial power degrees, sorry.
Oh, okay, so it's 8x2
8x squared.
and then 2x.
We'll gotta put a plus or minus. It's 2x positive or negative. We look to the left, and whatever sign there is, whether it's positive or negative, there's nothing there, so it's positive. Keep talking.
And then minus.
There you go. Okay. Abby, middle one.
4x squared plus 3x.
Okay, sounds good to me. Hannah, last one.
5.
You got it. Just say it.
5x.
To the third power.
Plus 4x minus 1.
That's the answer. Good job. All right. Questions on putting something in standard form. This is going to be something that you're going to do in Algebra 1. We can't let one chapter do we use that in geometry. But algebra 2, pre-calculus, calculus, and higher standard form, we use all the time. Now they'll say, first step, it'll say, hey, there'll be this really big complicated thing they ask you to do. And step number one will be put the thing in standard form. You're going to use it all the time. All right, the last of the pain, we got the most to write. Okay, we're going to give these polynomials 2 different types of names. Like we're going to give it a name, like Fred, Joe, that sort of thing, right? It's going to have 2 names. It's not a first and a middle or a first and a last. They're just 2 names. We're going to give one name based upon its degree. So a degree 2 is going to get a specific name, Fred. Okay. Secondly, we're going to count how many terms. You have 3 terms, it gets a specific name. The table that you see in front of you in box number 6 is where you're going to write these 2 tables. Okay, you're just going to recreate what you're about to see. One's called a degree name and one's called a term name. And yes, absolutely. The first time you learn this, you can mix this up, which is why you need to have it written down. It becomes a lot easier once you use it frequently, and next year we'll use it frequently. So here we go. So the first one, it's going to be a quick table. We're going to call it degree name. Here's the table. If you're a degree 0, you don't have to write examples unless you want to. If you're degree 0, we call you a constant. In fact, you've heard me say that. And I say, look at the constant. I'm asking you to find the degree 0 term of the polynomial. If you're degree 1, that's just x all by itself. X is the first term. We call it linear. You solved linear equations this year. You graphed linear equations. If it's to the second power, it's called quadratic. If it's to the third, we call it cubic. As the numbers go up, we do have other names for it, but in Algebra 1, we kind of stop after something to the third power. Once it becomes to the third power, we just call them 4th and 5th and 6th and 7th degree polynomials.
What does quadratic even mean?
Let's table that for a discussion next year. Okay.
Get linear, constant, and cubic.
Let's talk about it next year. Okay. 0 is constant, 1 is linear, 2 is quadratic, 3 is cubic, and anything higher than a 3, you just say whatever the number is. Hey, it's to the 21st power. It's a 21st degree polynomial.
So you have to memorize this?
You will have these memorized, absolutely. We use it every day. I mean, every day we say, look at the linear term, look at the quadratic term, look at the cubic term. Every day in Algebra 1. We good? You don't have to write the examples. Okay, we're not done. We got to write the second table down. Okay, we good? Second table, right? Second table is how many terms. You're literally monkey method, counting how many terms. How many things are separated by addition, subtraction. If there's only one thing, well, we call it a monomial. Like we already wrote that one down. Yeah. If there's 2 things, like this right here, 2x plus 9, there's 2 things. We say it's a binomial.
Wait, shouldn't
2. Therefore, if it has 3, we're going to call it a trinomial. And then there are higher ones, but at that point, we're like, okay, I'm not done with this. We call them nth degree polynomials. Any number you want it to be. That's a whole number.
So it can be imaginary too.
No, it has to be a whole number. So if there's 21 terms, we just call it a 21 term polynomial. We don't say whatever the number is for 21. Not dodeca.
Don't forget the worksheet.
Okay. Tonight for homework.
Okay.
I didn't forget. Tonight for homework, it is as simple as you would think. It's going to ask you to name it by degree and by term. So stop what you're doing, look at the board. Let me do a couple for you, and then we're out of here. All right. So tonight for homework, they're going to ask you to use both of these that you just copied down, and they're going to give you that. By degree name. Hey, what's the highest power here?
6.
Power. So it is a linear. By term name, how many terms are here?
3.
How many things are separated by addition or subtraction? So it is a binomial. This is a linear binomial. In standard form, there it is. It's a linear binomial. this is what your homework will be. It's not that complicated. All right, Angie is going to hand them to you on your way out. She's already standing there. Hand this to Angie. Angie, you gotta make sure that everyone, this to Angie. Make sure that everyone gets one as they leave. What? You can talk to anyone else that copied down in their notes. Talk to anyone else that copied it down.
But everyone's like swarming her.
All right, Donovan, that does it for today. We will see you tomorrow. Who's here? Donovan and Priscilla. If you guys have any questions, send me a chat or an email. I'll be happy to answer it.
Hey, I have a question. Could I see the calendar again?
Oh, by the way, Donovan, unlike when I usually leave the test up for a couple days, you will have less than 12 hours to take this test. So for instance, we are in period 4 right now, or, I'm sorry, period 3 right now. So the math test, which will be on Wednesday, I will make it appear at 10 o'clock in the morning, and you will have from 10 o'clock to midnight to get it done, and that's it. It will disappear, and you won't have a chance to take it. You have to take your final on Wednesday.
By 12 o'clock?
Lastly, you need to get your math book to me sometime between now and next Friday.
Okay.
Sounds like a plan?
Yep, I got it.
See you tomorrow.